Hi, I'm Dr. Nadia Rao, and I build quantum accelerators for a living. So let me answer the 3 questions you actually asked. Can we build a quantum GPU? How would it perform against the chips we have today? And what would it unlock? But first, let me show you the machine we already worship. A single NVIDIA H100 GPU does close to 1,000 trillion math operations a second. Stack 8 of them in one box, and you're into the tens of petaflops. Chain a few hundred together, and you cross an exaflop, a billion operations every second. That fire hose of parallel arithmetic is exactly why GPUs run modern AI, render your games, and power the biggest simulations on Earth. The world's fastest supercomputer, El Capitan, chains over 11 million cores to hit 1.7 exaflops. And here's the beautiful thing about classical parallelism. It scales by just adding more identical hardware. Want double the throughput? Bolt on double the chips. That predictability is why GPUs conquered the computing world. So here's the question that keeps me up at night. If we have all that raw horsepower, if we can just keep stacking silicon forever, what could a quantum chip possibly do that this army of GPUs can't? To answer that, I have to show you the wall. Because for all their power, these machines slam into a barrier they can never brute force their way through. And it's not about speed, it's about nature itself. Back in the early 80s, Richard Feynman noticed something devastating. To exactly track n quantum particles on a classical computer, you need a list of roughly 2 to the n numbers, not n numbers, 2 to the power of n. At 300 particles, that's more numbers than there are atoms in the observable universe. So think about one small molecule. The Femco cluster that bacteria use to make fertilizer has a knot of about 54 electrons dancing in a quantum blur. Our exascale supercomputers, all 11 million cores of them, cannot simulate it exactly. The math explodes faster than any amount of silicon can ever catch up. That's the wall. Nature is quantum, and classical machines choke trying to fake it exactly.
So here's the idea that changes everything. If exactly simulating quantum systems is impossible because they're quantum, then don't fake it. Build your computer out of quantum stuff too. That's the qubit. Unlike a normal bit that's stuck being a 0 or a 1, a qubit lives in superposition, a weighted blend of 0 and 1 at the same time. And when you entangle qubits, their states lock together in ways no classical bits ever could. Here's why that matters. Every qubit you add doesn't add to the state space, it doubles it. 10 qubits describe over 1,000 amplitudes at once. 300 describe more than there are atoms in the universe. A quantum computer doesn't store that impossible list of numbers, it physically is that list, evolving under the same rules as the molecule you're trying to understand. It sidesteps the wall by living on the other side of it. But hold that excitement, because being that list is not the same as reading it out, and that catch is where the honesty starts.
Now, the honest part, because this is where the hype usually lies to you. A quantum GPU is not a faster GPU. For your games, your browser, your spreadsheets, your everyday AI, it would be the worst chip in the box, and it always will be. In fact, quantum gate operations are slow in raw terms, often around 100 nanoseconds each on today's hardware, while your classical chips fire billions of operations a second. Quantum doesn't win by going faster. It wins on a narrow set of problems by needing far fewer steps. Simulating molecules and materials, potentially an exponential advantage. Factoring huge numbers with Shor's algorithm, the thing that threatens today's encryption, exponential. Grover's search through unstructured data, only a quadratic speedup. Square root of n, helpful but no magic wand. That's the real menu, and most of computing isn't on it. When Google's Willow chip ran a benchmark in 5 minutes that they estimated would take a supercomputer 10 septillion years, that's a 1 followed by 25 zeros. Remember, that task was hand-picked to be quantum-friendly, and it's useless in practice. It proves the physics is real. It does not prove your laptop is obsolete. So, Can we actually build the useful version? Not yet, and I'll be straight with you about why it's so brutal. Qubits are heartbreakingly fragile. A whisper of heat, a stray photon, a faint vibration, and the quantum state decoheres, and your answer evaporates. To fight that, many of my chips run inside dilution refrigerators at 10 to 20 millikelvin, colder than deep space, a hair above absolute zero. And even then, individual qubits make far too many errors. So the real currency isn't the physical qubit, it's the logical qubit. One reliable qubit built by error-correcting many noisy ones together. That's the twist the headlines hide. IBM's 1100-qubit Condor, Google's 105-qubit Willow, those raw counts are not a quantum GPU. The real race is error correction. And the news there is genuinely thrilling. Willow hit below threshold error correction. The first time adding more physical qubits made the encoded qubit better instead of worse. And in late 2025, Quantinuum's Helios packed 48 logical qubits into 98 trapped ion qubits with 2-qubit gate fidelity above 99.9%. We are climbing. Here's the future I'm actually building toward, and it's not quantum replacing your GPU, it's quantum joining it. Think about how a GPU sits next to your CPU, taking only the jobs it's shaped for. A quantum processor will sit next to the GPU exactly the same way, a specialized coprocessor that grabs only the quantum-hard sliver of a problem and hands everything else back to classical silicon. And here's a piece people miss. That classical silicon isn't just a sidekick. It does the heavy lifting of error correction, decoding the noise in real time. This isn't a dream, it's being wired up right now. NVIDIA's CUDA-Q lets you program CPU, GPU, and quantum processor in a single workflow. And in 2025, teams stood up setups with quantum chips living inside active data centers, scheduled right alongside GPUs. The reason this hybrid model is the right one comes down to one contrast. Add more GPU nodes and your throughput grows in a straight line, linearly. Add error-corrected qubits, and the state space you can represent grows exponentially. So the quantum accelerator only earns its keep on the exponentially hard piece, and for everything else, the GPU still rules. They complete each other.
So what does all this actually unlock? Not everything faster. Something better. Remember FEMMOCO, that fertilizer molecule no supercomputer can crack? A future error-corrected quantum computer could, in principle, simulate it in days. And the stakes are civilizational. The industrial way we make fertilizer burns roughly 1% to 2% of all the energy humanity uses, while a humble bacterium does the same reaction at room temperature. Crack its recipe and you reshape agriculture and the climate. That's the real prize. Quantum simulation of chemistry and materials. New drugs designed atom by atom. Cleaner batteries, better superconductors, catalysts we can't even imagine yet. And the exciting part is, this payoff might arrive before we ever build a perfect, fully fault-tolerant machine. In late 2025, researchers began showing early, verified quantum results on real materials. A first glimpse of the gap opening up between what quantum can do and what classical machines can't. But the reality check keeps me honest. Back in 2019, cracking modern RSA encryption was estimated to need around 20 million noisy qubits. By 2025, clever new algorithms had slashed that to under 1 million. And research keeps pushing the number down, but even under 1 million is far beyond today's hardware. Credible roadmaps, IBM's Starling in 2029, million-qubit machines around 2030, put the real payoff years out. So the quantum GPU isn't a bigger hammer. It's the only tool shaped like the lock. And its greatest strength, being a quantum system, is exactly why it can never replace your GPU, only complete it. If this blew your mind and you want more ideas like it, dive into the other videos on the channel. This has been Duck Fiction Lab.